Here we have AP calculus AB problem. Okay, let's go with the information. Determine the open intervals where the graph of f of x equals to negative 1 over x positive 1 the whole square is concave down. Whenever I want to find the open intervals where the graph of a function is either concave up or concave down, first I have to define the domain of the given function. Okay, when I look at the given function carefully, here I have a rational expression. So because it contains a variable x in denominator. Okay, to define the domain of this function, I have to get the value of the variable x for which the denominator over here becomes 0. Because if the denominator becomes 0, then the value of this fraction becomes undefined. That is, the f of x is undefined. So that value of x has to be excluded from the domain. Okay, now to get the value of x for which the denominator over here becomes 0, I have to equate this denominator to 0 and solve for x. Okay, let me do it. So x positive 1 the whole square is equated to 0. Now to solve for x, I have to get up the exponent 2 over here. For that, I am taking square root on both sides. When I take square root on both sides, the square root and square root cancel out. I am getting x positive 1. Square root of 0 is still 0. Now let's subtract 1 from both sides to solve for x. Then I'm getting x equals to negative 1. That is, when I plug in x equals to negative 1 over here in this denominator, negative 1, positive 1. So the denominator becomes 0. Then the value of the fraction f of x, the value of the function f of x is undefined. So this negative 1 has to be excluded from the domain. So let's consider any real value other than negative 1. So what will happen over here? So for any real value of x other than negative 1, so f of x is defined. So the domain of the function f of x is all real numbers except negative 1. Okay, now I have defined the domain of the given function. So now what I have to do is I have to find the first derivative and second derivative. Whenever I want to find the intervals where the graph is concave up or down, concave down, I have to find the first derivative and second derivative. So if the second derivative of the given function is greater than 0 for some value of x, then we have to say the graph of the given function is concave up. If the second derivative is less than 0, that is negative for some value of x, we have to say the graph of the given function is concave down. Okay, so for that purpose only, I am saying that we have to find the first derivative and second derivative of the given function. Okay, now let me write this function as it is. It is f of x equals to negative 1 over x positive 1 the whole square. Okay, before I start finding the first derivative, what I have to do is I have to move this x positive 1 the whole square to numerator. When I move this expression from denominator to numerator, the exponent will change its sign. Already it's positive, it will become negative. So and also it will be multiplied by this one. Then I'm getting x positive 1 whole to the power of negative 2. Okay, now we can start finding the first derivative of this one, that is f prime of x equals to negative. So to get derivative of this one, I can use the power of derivative. That is, I have to bring this exponent 2, negative 2 in front of x positive 1 and subtract 1 from this negative 2. Let me bring this exponent negative 2 in front of it. Then I'm getting negative 2 times x positive 1. Negative 2, negative 1. So far I have completed derivative only for the exponent negative 2. By chain rule, I have to do further derivative for the base x positive 1. So when I find derivative of this constant positive 1, it will become 0. When I find the derivative of this x with respect to x, it will just become 1. By chain rule, when I find derivative of this base x positive 1, I'm just getting 1. Okay, now let's do some simplification. F prime of x equals to negative times negative is positive. That is positive 2 we are getting over here. 2 times this number 1 is still we are getting 2 times x positive 1 whole to the power of, when I combine negative 2 and negative 1, I'm getting negative 3 as the exponent. Okay, now what I can do is I can start finding the second derivative, that is f double prime of x, that is equal to, here this is a variable because it contains x. So the variable over here is multiplied by the constant. When I find derivative, if there is a constant multiplied by the variable, then I have to keep the constant as it is and I have to find the derivative of the variable alone. So to get the derivative of this stuff, again I have to use the power rule. That is, I have to bring this exponent negative 3 in front of x positive 1. Let me bring this one times x positive 1. I have to subtract 1 from this exponent negative 3, then I'm getting negative 3, negative 1. So I just use the power rule. So far I have completed derivative only for the exponent negative 3. By chain rule, I have to further derivative for this base x positive 1. Already we know that the derivative of this x with respect is just 1. That this derivative of this constant 1 is 0. So finally, the derivative of the base x positive 1 is just 1 by chain rule. So f double prime of x equals to 2 times negative 3 is a negative 6. Negative 6 times this number 1 is a negative 6. Negative 6 times x positive 1 to the power of negative 4. Okay, now let me write f double prime of x equals to negative 6. Since this x positive 1 is having negative exponent, so we can change this negative exponent as positive by moving this particular term to denominator. So then we get negative 6 over x positive 1 to the fourth power. Now I got the second derivative of the given function, that is f double prime of x equals to negative 6 over x positive 1 whole to the fourth power. Okay, according to the question, we have to find the open intervals where the graph of the given function is concave down. So usually to get the open intervals where the graph is concave down, so we will equate this f double prime of x to 0 and solve for x. So when I equate f double prime of x to 0, I am getting negative 6 over x positive 1 whole to the fourth power equals to 0. I won't be able to solve for x in this equation. So by equating the second derivative to 0, we don't get any value for x. And here we can consider an important stuff over here. So here x positive 1 is having even exponent. So whatever value we have for x, whether we have a negative value or positive value, but x cannot take negative 1 because it has been excluded from the domain. Even if I take x equals to negative 1 over here, it will become 0. So then it becomes undefined. That is, the second derivative becomes undefined. So except negative 1, if I consider any real value for x, so positive or negative, and whatever value we are getting for this x positive 1, positive value or negative value, but always this whole stuff will be positive because of the even exponent 4. So for example, if I take x equals to negative 5, what will happen? Negative 5 positive 1 will become what? Negative 4 to the fourth power. It will be positive because of the even exponent. So for any negative value or positive value for x over here, always this is positive except x equals negative 1. Since this is positive, and so here we have a negative value in numerator. Already we know that this is positive. So here a negative value divided by a positive value, always this is negative, that is less than 0, except x is not equal to negative 1. We should not consider this value because it is excluded from the domain. Okay, now to get the intervals where the graph of f of x is concave down, we can draw a number line. So now we can plot this negative 1 on the number line, which has been excluded from the domain. On the left side extreme on the real number line is negative infinity, and the right side extreme is it's positive infinity. Okay, so here using this negative 1, we can split up the real number line into two intervals. The first interval is negative infinity comma negative 1, and the second interval is negative 1 comma positive infinity. So if I take any value in this interval, the first interval between negative infinity and negative 1, so I am writing open intervals because a question targets only the open intervals where the graph of the given function is concave down. Okay, now let me consider the first interval, that is values between negative infinity and negative 1. So let me take a random value in this interval, for example, say negative 2. So when I take x equals to negative 2 and plug in into the second derivative, what will happen? So again, it will become negative. Already we have discussed this, because when I plug in negative 2 over here, negative 2 positive 1 will become negative 1. Negative 1 to the fourth power will become positive. So a negative value divided by a positive value is always negative. So the second derivative becomes negative. Since the second derivative becomes negative in this interval, so in this interval negative infinity comma negative 1, so the graph of the given function f of x is concave down. Now let me consider a random value in this interval between negative 1 and positive infinity. It's 0 obviously. When I plug in x equals to 0 over here, 0 positive 1 is 1, 1 to the fourth power is 4. So we are getting a positive value. So a negative value is divided by a positive value. Again we are getting negative value for f double prime of x in this interval. So f double prime of x is negative in the first interval and the second interval as well. So in both the intervals, the second derivative is negative. Since the second derivative is negative, the graph of the given function is concave down in both these intervals. In interval notation, usually we write a union between these two intervals. That is, when x takes a value either in this interval or in this interval, or means we use a union. Okay, so the open intervals where the graph of f of x is concave down are negative infinity comma negative 1 or negative 1 comma positive infinity.